In this lesson, we're exploring the prospect of a side-side angle congruence theorem. So again, let's review. We know that angle-side angle is a triangle congruence. We know that side angle side is a triangle congruence. We know that side 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 is a triangle congruence. And in the last lesson, we showed that angle angle side is a triangle congruence. So in order to investigate this side-side angle congruence possibility, the instructions have us at making a 30-degree angle and then labeling a point B on a side of angle A so that the length of segment AB will be 6 centimeters. So remember that anytime you're building something new, you start with a random ray. And in order to make a 30-degree angle, I mark at 30 on my protractor, and I draw this ray, and 6 centimeters on this side would be here. So here's A, here's B. It says now draw BC so that BC is 4 centimeters. To do this, open a compass to a distance of 4 centimeters. So I'm going to take my ruler and take my compass and basically open my compass setting up to 4 centimeters. And I can mark it here. But notice I could also mark it here. So what does that mean? That means that if I have this side length and I have this side length and this non-included angle, I can actually make 2 triangle ABCs that I hope you realize are most assuredly not congruent. And we've seen this before. We did this with the side-side-side triangle congruence. But now we have confirmed, is it possible to draw only one triangle ABC with the given side length? No. 2 triangle ABCs were possible. So, do we think that side-side angle is sufficient to prove triangle congruence? No. Given 2 sides and the non-included angle, more than one triangle is possible. So your friend says that there's a special case where side-side angle can be used to prove congruence, and specifically that non-included side would be a right angle. So is your friend right? So let us consider if I have, again, blank ray, and this time the angle that I'm making is a 90-degree angle. So if I know this side length, and I know this angle, and I know this side length, well, if I know this, let's call it B, and I know this, let's call it C, hopefully you kind of already noticed where I'm going with this. We have a theorem, namely Pythagorean Theorem, that says if I know 2 sides of a right triangle, I can find the third. So your friend is actually right, because Pythagorean Theorem can be used to verify that the third sides would be congruent. Okay, so a little bit of vocabulary, once again, to refresh your memory. When you have a right triangle, the side that is opposite the right angle is the hypotenuse, and the two sides that are forming the right angle are called the legs. So now, kind of, we're rounding out our discussion on how can we prove that two triangles are congruent. As I mentioned earlier, we have angle, we have side, angle, side, we have side, 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 angle, angle, side, and now we have what we call hypotenuse leg. So here, hypotenuse leg is stated for us that if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So you've heard me mention a few times in class that in order to prove that two triangles are congruent, we need 3 pieces of information. And now, oh my goodness, Mrs. Clouse, now you're throwing me for a loop and this property only has two letters. However, keep in mind that the wording of the hypotenuse leg theorem does mention the third piece of information. The third piece of information is that these have to be right triangles. And in order for them to be a right triangle, we have to know that there's a right angle within it. So here in example 1, we're going about proving the hypotenuse leg triangle congruence. So by the Pythagorean theorem, we know that a squared plus b squared equals c squared in this right triangle. And so that means that also d squared plus e squared will equal f squared. Okay, so it's given that AB is equal to DE, so that means that the length of AB equals the length of DE. So we're kind of using these letters to simplify that. Therefore, c squared equals f squared, and a squared plus b squared is going to equal d squared plus e squared. Now, we know that BC is congruent to EF, so that means the length of BC equals the length of EF, and so variable A equals variable D. So substituting those in this equation, I have that a squared plus b squared here equals a squared plus e squared. So now, since I have an a squared on both sides of the equation, I can subtract a squared from each side of the equation to show that b squared will equal e squared. And when I take the square root of each side, b will equal e, and this will show that AC is congruent to segment FD. And therefore, the triangles would be congruent by side, side, side. Triangle congruence. So in this your turn, they're asking us to determine whether there's enough information to prove that these two triangles are congruent. Well, based on the markings, we know that triangle VWX and triangle YXW are right triangles. We are given that VW and XY are congruent legs of the right triangles. And by reflexive property, we know that WX is congruent to WX. So the hypotenuses are congruent. Therefore, yes, by hypotenuse leg triangle congruence. Here, we're doing a bit more formal proofs. So in example 2, part A, the proof is done for us. Let me talk you through it. So they've given us that these angles are right angles. They've given us that PS is congruent to RQ, and those are the legs of those two right triangles. SQ is congruent to itself because of the reflexive property. And since the hypotenuse and legs of these right triangles are congruent, yes, the triangles are congruent by hypotenuse leg. In part B here, they've given us the statements and they want us to come up with the reasons. So, once again, we are given that J and L are right angles. We are given that K is the midpoint of segments JL and MN. So they've used that K is the midpoint of these segments to say that JK is congruent to KL and that MK is congruent to KN. And since those are a leg and hypotenuse of the right triangles, the triangles are going to be congruent by hypotenuse leg triangle congruence. Let me go back and clarify this. I said that they used that K is the midpoint. Well, that means that what they used was the definition of midpoint. I like that they're asking you this question in the reflect. Is it possible to write the proof in part B without using the hypotenuse leg triangle congruence? Well, if all they had given us was that K was the midpoint of this segment and this segment, I could have still been able to make this statement in statement 3. But notice what else we have in this diagram. We have that angle JKN and angle LKM are vertical angles. So yes, we could have done this without hypotenuse leg. We could have stated that angle JKN is congruent to angle LKM by the vertical angle theorem. And then the triangles would be congruent by side angle side. Triangle congruence. In this next proof, we're being asked to write the whole proof out. Yep, they're asking us to do the whole thing on our own. So there's not a whole lot of space left here on page 297, so I'm going to do it on a separate sheet. So we would have statements and reasons. Starting with the given. Angle CAB and angle DBA are right angles. We are also given that AD is congruent to BC. That's given. And let's take a close look at these two triangles. So the triangles that they're wanting me to prove congruent are triangle ABC and triangle BAD. So what have we said is congruent so far in our proof? We've said that AD, this hypotenuse, is congruent to BC, this hypotenuse. Okay, so we've got hypotenuses that are congruent. Now we need legs. Well, once again, notice that these triangles are sharing a common side. They're sharing segment AB. And I've tried to make a big deal to you and stress to you over and over again that if you have a common side or a common angle, chances are really, really strong that you're going to use it. And here we are using it. Segment AB is congruent to segment AB because of reflexive. And since AB is a leg of the two right triangles, I can say triangle ABC is congruent to triangle BAD by hypotenuse leg triangle congruence.